They have a high ductility and malleability because there are non-directional metallic bonds that still hold the cations together even if the position has been changed。嗱，呢度係講啲咩呢？其實我覺得sorry， 我唔想揀呢度，反而想揀下邊。嗱，其實呢度講咩呢？就係點解會係 malleable and ductile 呢？ Because when a force is applied by hammer or what? By hammer, then the layers of metal iron will slide over one another， 即係褪咗位。But at their new position, there are still delocalized electron, right？ 係啦，因為去咗褪咗位，其實唔係完咗嘅喎，褪咗位其實嗰啲 sea of delocalized electron 係周圍係噶嘛，所以就好似膠水咁繼續黐住咗嗰啲 metal iron， 所以佢哋只係褪咗位，只係變形而唔係碎開。Okay? When a force is applied, the layers of metal can slide over one another, but the metal does not break because of the non-directional metallic bond. What's mean by non-directional? 即係冇方向性，我唔係話淨係向上吸住，淨係向打橫吸住，而係四方八面嘅。呢啲 electron 喺四方八面噶嘛，所以咧即係呢粒 electron 其實同呢個 ions 有 attraction 啦，即係我放大啲，即係呢粒 electron， 即係當我而家係講呢粒 electron， 其實係同呢個 ions 有 attraction， 同呢個有啦，同呢個有啦，四方八面都有 attraction 嘅，咁所以咧佢褪咗新嘅位置之後咧，其實都繼續吸住咗啲 metal ions， 而唔係斷開咗咯。OK， 因為啲電子咧係吸住咗佢哋啊。新嘅位置即係就算我褪咗位，其實新嘅位置都有好多電子㗎，有 sea of delocalized electron， 所以仲可以吸住啲 metal ions， 所以佢就只係褪咗位變形，而唔係冇咗咯，唔係碎開咗咯。And we describe it as non-directional metallic bond， 即係唔係淨係話我淨係打橫呢個位會吸住，唔係啊，係四方八面都吸住咗。So they are malleable and ductile because we explain malleable and ductile together, even though they are not the same, but the reason are the same。佢哋即係變形咯，爭在 malleable 咧就係、即係主要係變形啦 ，ductile 咧就係 into wires 啦，即係拉長佢啦嚇 ，into wire 就係 ductile 啦。Okay, then let's go to simple molecular structure. So for this one, this is new to you, simple molecular structure. So first of all, I have defined which substances have simple molecular structure. Are the substances that form covalent bonds with others, and they are not taking giant covalent structure， 即係話只要係 form covalent bond， 即係啲 non-metal form 嘅嘢啦，跟住佢哋唔係 giant covalent structure 嗰啲咩 silicon 啊、graphite 啊、silicon dioxide 啊、silicon and boron。If they are not these giant covalent substance, they will be simple molecular structure。即係話只要唔係嗰啲，而佢哋係本身 non-metal 係啦 non-metal 嚟嘅。form 嗰啲elements 或者 compound 啦，佢哋就會係呢一個 structure 啦。They will be simple molecular structure。咁就易啲界定，你記住幾隻勁嘢，其他唔勁嗰啲咧就係 simple molecular structure。So for this you can see simple molecular structure, not giant structure 啦。今次就唔叫 giant 啦，我哋學咗幾個 giant， 而家學咧呢個叫 simple molecular structure。So first of all, their atoms are held together by strong covalent bond. For example, for chlorine, this is Cl2. In between the atoms of chlorine, so this chlorine atom and another chlorine atom, they are attracted by strong covalent bond. So in between atoms there are strong covalent bonds, but there are only weak van der Waals forces between molecules。嗱，即係話咧，呢度講咩咧？就係話，如果係 atom 同 atom 之間咧，就係 strong covalent bond， 正常啦，即係不嬲我哋知道佢哋 sharing of electron they will form single covalent bond。Covalent bond are strong, but for this molecule and then this molecule in between them, there are only weak van der Waals forces class. Only weak van der Waals forces between molecules. So only weak van der Waals forces exist between molecules. Okay, then maybe we talk about this later. So for this structure, this is iodine molecule. So first of all, iodine is a solid. Solid 嘅話咧就會都即係其實應該咁講 ，simple molecular structure 咧可以係 solid、liquid or gases, but their melting point and boiling point are generally low, not several thousand degree。即係我哋唔係幾千度㗎佢啲 melting point， 佢哋主要係 low melting point、low boiling point。咁點解咧？就係 for example for iodine, if we want to melt iodine crystal, that is solid. So if we need to melt iodine, what we need to break is the weak van der Waals forces, not the strong covalent bond, okay? Because when we need to melt iodine, we just need to separate this molecule apart. We don't need to break the covalent bond, alright? 嗱，因為我哋其實要 melt 佢咧，其實係主要係將啲 molecule 分開遠啲，而唔係將個 molecule 裏邊啲 atom 拆散，唔係，因為如果喺 liquid 嘅時候佢仲係 iodine 嚟噶嘛，咁所以其實唔係拆啲 atom， 而係拆啲 molecule 同 molecule 之間嘅 van der Waals forces。So because we just need to break the weak van der Waals forces, which is weak. So we just need a small amount of energy in order to break the weak van der Waals forces. So the melting point and boiling point are lower when compared to giant covalent substance or giant ionic substance. 明唔明啊？因為我哋要拆嘅嘢係弱嘅嘢啊，我哋唔係要拆 atom 同 atom 之間，因為去到 liquid 嘅情況，當我畫翻出嚟啦。去到 liquid 嘅情況咧，佢係只係啲 iodine， 即係當我而家 liquid 啦呢度 ，iodine 同 iodine 咧分得遠啲，佢離遠啲，但係仲係 iodine 嚟㗎，呢啲係 iodine 嚟㗎，呢啲係 iodine 嚟㗎，只係將佢分開遠咗。咁所以其實拆嘅嘢咧，記住拆嘅只係拆 weak van der Waals forces， 而唔係拆個 strong covalent bond， 所以個 energy requirement will be much lower, and then the melting point and boiling point are lower. Alright? So this is dry ice, carbon dioxide solid. So when we need to melt the dry ice, we just need to break this. The simple molecular structure, we just need to break the weak van der Waals forces. Alright? So the melting point and boiling point of them are much lower. So highlight this, low melting point and boiling point, because molecules are held by weak van der Waals forces. Little energy is needed. And then they do not conduct electricity because no mobile ions or delocalized electrons. So highlight also this. Covalent bonds are not broken during melting and boiling. Only weak van der Waals forces are needed to be overcome. Alright?